Right, good morning, Year 11. A pre-recorded one today. Thanks for all your work last week, and thank you for the feedback. Interestingly enough, there was quite a mixture, and there were people who preferred the pre-recorded lessons, and there were also people who preferred the live lessons. So I think what we'll do, sort of going forwards, is we'll do a mixture probably, and it will depend sort of how busy my day is with other live lessons. If I've got a really busy day doing lots of live lessons, I might set you something pre-recorded, and if I've got a day that's not quite as busy with other groups doing live lessons, then of course we'll do them. So we'll have a bit of a mixture, and sometimes I might even just set you some sort of exam questions from Dr. Frost or something like that. So today we're going to look at something, a fairly simple mathematical idea, and then we'll look at some somewhat tricky questions. But we've got our starter first of all, so if you want to pause the video and have a go at these 5 questions, that would be a good idea to start with. Okay, and we'll do the answers now then. So A is directly proportional to B squared, so that means that A is going to equal something, which is our constant of proportionality, times B squared. When A is 500, B is 10, so we end up with 500 equals 100k, so k is 5. So therefore A equals 5b squared. So find A when B is 20. Well, A is going to be 5 times 20 squared. 20 squared is 400. 5 times 400 is 2000. Right, if we go over to here, line 1 has gradient 4 and passes through the point 3, 10. What is its equation? So if we just go for y equals mx plus c, then y is 10, the gradient is 4, the x-coordinate is 3, plus c, so we see 10 equals 12 plus c, so c is negative 2, so my line is y equals 4x minus 2. Over here, the sum of the interior angles for an octagon. So for this one, you just want to use the formula n minus 2, so 8 minus 2 times 180. This will always work, so we want to do 6 times 180, and that's going to be 1080 degrees. So what's the size of each interior angle for a regular octagon? Well, if it's regular, it means each of the angles is the same size, so we can do 1080 divided by 8. And we're going to get our answer. So 1000 divided by 8 is 125, 80 divided by 8 is 10, so it's 135 degrees. Right, the orange one, solve 2x squared minus 5x plus 3 is less than 0. So we had a look at these last week. This one is going to factorise. So if you were to consider, say, 2x squared minus 5x plus 3 equals 0, you could factorise it to 2x and x, and then it would be x minus 1 and 2x minus 3, which means that if you were to sketch our parabola, it's a positive x squared, so it's going to be a U shape, and it's going to cross the x-axis at 1 and at 3 over 2, or 1.5. So 1, 1.5, and then there's our parabola. So where's that parabola less than 0? Well, you can see that it's less than 0 there. So our answer to this question is to say that x needs to be between 1 and 1.5. And finally then the red one, 1 and 11 twelfths to the power of minus a half. So with a question like this, 1 and 11 25ths doesn't seem to make a whole lot of sense to work with. So if we instead turn it into an improper fraction, It's going to be 36 over 25. That's a lot nicer because now these are both square numbers. So power of minus a half means that we need to, the negative power means the reciprocal, and the power of a half means square root. So it's going to be 5/6 as our answer. And that's it. So hopefully those are okay. If you didn't get any, I hope the explanation makes sense. And so on to what we're going to look at today. So as I said, a fairly simple topic, which is the prime factorisation of numbers. And in our live lesson this week, we're going to have a look at some ideas for why the prime factorisation is useful. But for now, we're just going to basically talk about what it is. So firstly, we'll just consider a prime number. So just as a really quick reminder, prime numbers have exactly two factors. That's the definition that you want to use, because then you won't have any ambiguity over whether numbers like 1 are prime or not. 1 is not prime. So prime numbers have exactly two factors. And then there's something called the fundamental theorem of arithmetic, which is a very grandiose term. And what that states is each positive integer has a unique prime factorisation. Okay, so the prime factorisation is just, what we understand as product of primes. We'll have a quick look at a question. So example, find the prime factorisation of 560. So factorisation just means that we want to write it as a product. Like when you factor something, you write it as in terms of a product of its factors, and specifically we want the factors to be prime numbers. So the way to do this, you might do it with a factor tree, but I'm going to do it just going across the page instead, is we're just going to consider factors of 560. So we might start with 56 times 10, and then you might split them from there. So 56 is 7 times 8, and 10 is 2 times 5. And the idea is to just keep going until you get prime numbers. So 7, 2 and 5 are prime, 8 is 2 cubed. There we go, and then we'll put it in index form and in ascending size of primes. So the smallest prime is 2, and we've got 4 of them in our product, times 5 times 7, so that's 16 times 5, which is 80, times 7, which is 560. Okay, nice and easy. That's all we're going to do today. As I said, we're going to look at why it's useful in our live lesson, but I've got some questions which I'll give you on a worksheet now. They start off a bit boring, but they will get you thinking, I think, as you go through them. There's some quite nice questions in there. So just spend a bit of time now having a go at them, and then in the last sort of 5 or 10 minutes of the lesson, have a look at the answers, which I will share with you at 10 past 11, so that you can use the last 10 minutes just checking. So good luck. If you need any help, or if you want to ask any questions, I will be available. I'll do a drop-in Teams meeting. And the same goes for anything from last week. If there are any questions from the work we did last week that you want to drop in and ask about, now is a really, really good time. Okay, so remember we did the quadratic inequalities, and we also did the simultaneous equations with one linear and one quadratic. So good luck with the questions, and I will see you for a live lesson another day. and you can expect to get the answers at 10 past 11.